I typically talk about graphs and networks interchangeably. I use the terms interchangeably. I probably shouldn't. The graph, I think, maybe refers to the formal properties of a network, and a network refers to the physical properties of a graph. At least that's how I use it. But I'll use both terms in this talk. I want to talk about the graph, Web 3, e-learning 3, and how the graph changes and reshapes learning. And I'm going to need to kind of back up a bit for that, and I'm going to need to talk a bit about the history of the web and all of that. But we'll get back to the point. We'll get back to learning, I promise you, because at the end of all of this, the outcome is learning. So where do we begin? Let's begin with the beginning of the World Wide Web to begin with. The web is it began as a decentralized network of interconnected servers and websites, but over time we saw that it became dominated by platforms like Google and Facebook and Twitter, and etc. So what happened? Well, the original web, the original internet, were hard to use. We found that they needed an index. We had our own bookmarks, but we couldn't really share those. We began, by we I mean the people who were on the internet. We began by creating indices. We had, for example, the World Wide Web Library, things like that. And this was originally the domain of academic libraries, the universities, putting up things like Gopher and Archie and Veronica and similarly named things. But this was eventually delegated to services like Alta Vista and Yahoo. And over time, the human activity of indexing the web was replaced with the functionality, the computational functionality of search engines. And over time, this began to be not just for indices, but for things like articles, messages, journal articles, all of the rest of it. And so the platform gradually became the predominant thing that we use to interact with each other online. Something called Web 2.0 was born, and out of that, of course, e-learning 2.0. And we gave up on the idea of this distributed web and began to use platforms to host our content and manage our connections with other people. And this brings us to today. And what's happened is because we can't store and share our own data directly, even the simplest exchange requires an intermediary, a trusted platform of some sort, to hold our content and to remember, really, what we've said to each other. And these platforms have become the source of our sharing, the source of our information, the source of truth. But this relationship has become strained. You look at this article, this is from 2011, when Apple decided it was going to take 30% out of subscriptions to iPads. They had the power, they had the central authority, they became the source of truth. What has come to be known as Web 3 is a response to this. Web 3 is the idea that each of us should be able to manage and share our data directly with each other. And it's evolved over time into a specific set of protocols that it creates and defines that structure. Now, this is an unfinished project, um, and it's still evolving. And that brings us to the graph. And the graph is the conceptual basis for Web3 networks. And sometimes it's difficult to see this, right? Because each domain, and we'll talk about a few of them, defines the graph slightly differently. They can't even get the name of the thing right. Graph, network, graph, ecosystem, community, whatever, right? And so each of these have different names for different parts. And as well, Web3 is not just a concept, it's actually the name of a software library written in JavaScript to support data sharing and interaction by means of a blockchain network, and specifically the Ethereum blockchain network. We're not gonna talk about specific blockchain networks. But the idea here is that we have this distributed web. Our data is recorded in this distributed web, in this blockchain, and then we use this blockchain for contracts, applications, whatever else we wish to do with our data. And you can see all the different concepts, like contract, IBAN, personal accounts, get hash rate, get balance, etc. Now, we don't have to use blockchain in order to use a distributed network. There are other ways of doing distributed networks. This course, eLearning 3.0, is a distributed network. But as we'll see later, the blockchain offers an answer to a key question that comes up when we're using any sort of network technology, any sort of distributed system. And that's this: why should I believe anything that I hear over this network? But let's not get ahead of ourselves. Let's stay with talking about the blockchain, the graph, the network, and we'll move slowly but surely to something like an answer to that question. So, okay, we have the terms graph and network. And as I mentioned, I tend to talk about them referring to pretty much the same sort of thing, right? So as I said, I use the graph when I'm thinking of the formal properties of a network. I use the term network when I'm thinking of the physical properties of a graph, but really I could sort of use them interchangeably. Now, there are some common graphs or networks that we're all familiar with. This is not in any way an exhaustive list. But for example, there's the social network, whether it's on Facebook, Twitter, or whether it's just thought of as a meta concept, right? It's made up of people and sometimes bots pretending to be people, connected by means of friending or following or adding to a buddy list or putting in circles or whatever, and interacting by means of texts or messages or lolcats or whatever, right? So that's one network. Interesting network, a lot of study been done on it. Another network is a neural network, which is made up of neurons, makes sense, or in a computer, artificial neurons. So we have the brain kind of neural network and the artificial intelligence kind of neural network. And these are made up of neurons or units, if you will, and they're connected by means of axons or connections, interacting by means of pings or signals or whatever. So that's a different kind of network, again, extensively studied. We can also think of a financial network. This is where blockchain comes in. It's creating a financial network for us. It's made up of accounts, or maybe it's made up of people, or maybe it's made up of web IDs or whatever. which may have balances of various sizes, where the balance, say, is made up of coins or tokens or whatever. And these are connected through transactions and contracts, and that's how the interaction happens. The interaction is created by recording a transaction in the blockchain. Still, though, same kind of concept. We have nodes, we have connections, we have interactivity. And then even we can have a semantical network, such as the semantic web. I could put up a big picture of the semantic web there, but I won't, because I'm lazy. Where what we have is, well, in resource description framework, for example, resources, whatever those may be, people, books, libraries, institutions, genomes, whatever, right? And they're connected conceptually through semantical relationships, such as is part of or belongs to. And they interact through logical relations with each other, and then you have different kinds of semantic web, RDF, logical processing things, query languages, etc. All of these are the same kind of thing, and this is one of the key things to realize about the new environment we're moving into. Blockchain is just the latest of a series of conversions from centralized mechanisms to graph-based mechanisms. And these have been going on for several decades. I've certainly talked about them for years. George Siemens has talked about them. Other people have talked about them. So we're not inventing something new here. We're just seeing some new dimensions to something that's been around for a while. And in these networks, in these new dimensions, the core idea is always the same. We have a set of entities, sometimes called vertices, sometimes called nodes, sometimes called units. Looks like my picture's not going to come up because, of course. And they can be even organized. They can be organized like a tree or like a graph or whatever. A tree is just a specialized form of graph. It's directed, it's acyclic, but it's a graph. So we have these entities, nodes, whatever, and they're connected to or linked to each other. And that's different from related to each other, right? That's different from saying something is bigger than something else or whatever. This is actually some kind of connection. When I talk about networks, I define a connection as a change of state in one node can result of a change of state in another node. But we don't need to be so precise. Basically, we've got nodes that are linked together or connected. These connections are called links, edges, connections, whatever, right? They can be pretty much, well, I guess you can call them you can't call them Fred. But you get the idea here. There's numerous names for these things. Now, what these do is they, as a collective entity, constitute what's called a distributed representation of a state of affairs. And here I'm linking to a pretty accessible article by Jeffrey Hinton talking about what distributed representation is. And basically it's the idea that there's no specific place where a concept or idea is located. If we think of ideas in the brain, right, like sentences in the brain, there's no specific place in the brain where there's a sentence. Rather, that sentence is distributed across hundreds, thousands, tens of thousands of neurons. And the same is true with the other kinds of graphs. There's no specific place where a community of people in a social network is. The community of people in the social network is where all the individual people are kind of collectively, and they move around because they're people. Similarly with other kinds of networks. And so we have different kinds of distributed representations of different kinds of states of affairs. In a social network, the state of affairs might be a community. In a neural network, it might be a concept. In a financial network, it might be an economy. In a semantical network, it might be a representational state. And these states of affairs aren't created and located in any specific space. Rather, the network itself, as a whole, contains that space. Now, we've talked about this before in previous courses. If you took the connectivist courses that we offered, we explored the idea of thinking of knowledge as a graph and learning as the growth and the manipulation of that graph. Or sometimes we talked about knowledge as a network. We talked about learning as the growth and manipulation of that network. And I talked about that in a short article I wrote called What Connectivism Is. And that's been around for quite a while. And the core proposition of connectivism is that the state of affairs contained in the graph or network is itself knowledge. And learning is the creation, development, and traversal of this network. What's changed in e-learning 3.0 is we pose and are required to answer in a significant way what makes it knowledge. Because it's just a set of connections. And this applies to any of these networks. In the semantic web, we're faced with the same sort of question, right? What is the source of truth of a distributed representation in the semantic web? What actually grounds ontologies or, say, assertions of trust in the web of trust? And these are precisely the sorts of questions that have led us to depend on platforms. We need some kind of concrete index or source of truth or authority or whatever. And so the platform, the trusted platform, becomes the source of truth, and the truth of these representations is grounded in the platform. But as we've seen, the truth of these representational states becomes, or these platforms become, untrustworthy in time. Untrustworthy for two especially significant reasons. One is if you have multiple competing platforms, say Fox News and CNN, or say the left-wing community on Facebook and the right-wing community on Facebook. And then the second reason they become untrustworthy is that the platforms, especially because they're centralized, are subject to being manipulated by bad actors. And we've seen that with, for example, the accusations of foreign interference in social networks in order to destabilize society and influence elections, etc. And so Web 3 ultimately represents a dissatisfaction with that solution. Web 3 ultimately represents a distrust of platforms and a distrust in centralized authority. And so what is being proposed by Web 3, or the various versions of Web 3, and that's going to include e-learning 3.0, is going to incorporate elements of identity immutability, and community in order to create what we might think of as a shared graph. Now, shared graph, that's true of social networks, it's true of financial networks. In a human brain, the shared graph is the human brain, right? So neurons constitute a shared graph of knowledge relative to a specific individual person. So, and then statements describing the interactions between entities or changes in the state of the entities are chained together. In, for example, the blockchain, they're chained together in something called a hash graph. And a hash graph is a way of cementing these assertions into place so that once it's been done, it can't be undone. And what's interesting, and we could talk about the mechanics of the hash graph, and I do have some stuff on that, but what's really interesting about that is that the hash graph is at once the outcome of these mechanisms and these interactions, but at the same time the source of truth for these mechanisms and the interactions. We interact in the graph or the network, and if the network is encoded properly, the network itself becomes the source of truth for these interactions. Now, this isn't just a coherentist theory. It's not simply because everything kind of hangs together in a logically consistent way. It's more than that, and I want to explore a bit about how it's more than that. So, what we have using these graphs really is a new type of content. These data structures are these distributed data structures that we can use and represent, etc. So one example is Bitcoin. Bitcoin is a new kind of thing. It's analogous to the concept of money, but it isn't money, right? It's something different. It's analogous to the concept of instantiating value in a token, but it isn't exactly that either. So, or another example, the collection of updated versions of software stored in GitHub. GitHub is a graph. In fact, it's a kind of hash graph, and in fact, it's something called a directed acyclic graph. And things like attribution networks, conceptual networks, websites, all of these can be represented using graphs, and when they become represented using graphs, they actually become a different kind of content. So let's contrast the graph as a form of content from traditional narrative structures. A traditional narrative structure is linear. It might be threaded, but basically it begins with a premise or a state of affairs or some other truth, and then it leads logically and conceptually from that beginning to some other truth, some other inferences, etc., to a conclusion, an outcome, a state of affairs that we've derived, deduced, etc. None of this is true of a graph. If there's a story, and there very often isn't a story in a graph, it's in the connection, in the links. If there's a source of truth, it's not at the beginning of the story. It's not premises or anything like that, but rather it's in how these links are created and maintained. So, if we think about it, as repositories of knowledge, graphs are a different kind of content from stories. Graphs enable the same data, for example, to be viewed from a variety of perspectives. We can look at a graph from this point of view, from that point of view, from that point of view. That's why it's not really a problem for me to think of using the same terms for graphs and networks, or to think of units and nodes and vertices or whatever. These just represent points of view on basically the same sort of thing. And then once we have this kind of thing, we can start doing manipulations and inferences from these data structures in a way we never could with a narrative structure. So I threw a resource into the course, which I probably shouldn't have, with all of these different things, right? Find mother vertex in a graph. Find k cores of an undirected graph, right? So k cores might be clusters or whatever. Transpose graph. Path in a rectangle with circles. You know, all these things you can do with graphs that you can't really do with a linear network, because all you can do with a linear network is go from the beginning to the end, maybe do a word cloud. So that's one thing. As dynamic systems, as systems that change and react to input, as systems where the connections between the entities or the nodes change, we get machine learning. And machine learning is the backbone of emerging technologies. We have unsupervised learning, sometimes thought of as deep learning, which can do things like clustering or reduction of dimensionality. Supervised learning, such as classification or regression, where we sort of know the kind of output that we're looking for. This is the kind of learning we might use, for example, if we're trying to use AI to grade essays. So we show the algorithm a whole bunch of previously graded essays, and then it uses those as a training set and then goes on to classify them A, B, C, D. And then reinforcement learning for things like robot navigation, skill acquisition, and the like. So these are things that graphs can do or can be used to do that typical knowledge representations in the form of linear semantic structures such as arguments, such as explanations, you know, the classics of traditional cognitive reasoning, they don't allow us to do these. Now, in education, as well as in, say, news media or the study of history, etc., we're drawn to the idea of the narrative, the idea of the single actor, the idea of the causal explanation. You know, the Napoleonic Wars were all about Napoleon, and there was nothing else. And that's okay, it's obviously an exaggeration, but you get the idea. And as Alex Rosenberg says in this article, these historical narratives seduce you into thinking you really understand what's going on and why things happened. But most of it's just guessing. Guessing about people's motives and their inner thoughts. But if we represent the same state of affairs as a graph, this serves as a corrective to this tendency. It helps learners understand that how each idea connects to the other. It helps us show how the entire graph grows and develops. It protects us from categorization errors and helps prevent things like confirmation bias. And we'll talk about some of these things in the future of the course, or perhaps in future courses based on new kinds of literacy that emerge from a network perspective on the world. But Laura Ritchie gave us a nice example in an article here. This is a study of music, and this is a breakdown on what you're going to spend your time on in music. And as you can see, 71% of your time is being spent on technical exercises, and then 10% on classical 7% on jazz, 7% on pop, nothing on hard rock and death metal, and then 5% on composing. And she suggested students might not find that very appealing, and I kind of get that, right? But that's because we're using just this plain, linear, numerical representation of what's being done. But if you show a different representation of the same concept, a roundabout, or as we call them here, traffic circle, I guess technically they're different things, but whatever. We can see how the tech exercises are actually at the center. And when I look at that and I can break that down into a bunch of different and related tech exercises that lead to jazz, lead to classical, lead to pop, lead to composing, and yes, even lead to death metal. Although it's not on the graph, but it should be, because death metal is important. So the key thing here is that by representing what's being learned as a graph, we change our perception of how we're going about learning and what it is that we're learning. And that's what's important. It changes our understanding even of where the knowledge comes from. Graphs and graph theory demonstrate in a concrete way how everything depends on something else. And this helps us place our understanding of ourselves, of our knowledge, and of our work into this wider context. And then hash graphs, the stuff, in blockchain, or for that matter, neural networks and machine learning with their machine learning algorithms, or with the different algorithms that can be used in a graph database. These take it a step further. They illustrate and instantiate the fundamental knowledge creation mechanisms that happen in a graph. You look at GitHub, for example, and we have things like cloning, forking, versioning, merging, right? These are manipulations in a graph that lead to something new. In the past, and I still hold to this, I've characterized these sorts of activities under the heading of aggregation, remix, repurpose, feed forward. But as you can see, we can get much more concrete and definitive descriptions of what can be done. There's a wide range of these algorithms. And although it's too much to say people should learn all of these algorithms, because that would be silly, these new mechanisms do form the basis of new kinds of literacies in order to learn about these new content structures, about these new data structures. And these new skills, aggregating, remixing, repurposing, etc., become the new way we learn, as opposed to, say, listening to or reciting a narrative. And equally importantly, probably more importantly, it changes our understanding of where this knowledge comes from. A graph or a network is not merely a representational system. It's not just a place where we store data and manipulate data. A graph or a network should be best understood as a perceptual system. The human brain is a perceiving thing. We don't just perceive on the edges with our senses and then do a bunch of logical inferences. The whole thing is a perceiving mechanism. And the graph, therefore, is not merely the repository of knowledge, but a growing and dynamic entity shaped by and in turn shaping the environment around itself. Which leads us to say, importantly, I think, that thinking and perceiving are not two distinct states. They are one and the same state. To perceive is to represent is to perceive. They're not two separate things. That has an impact on semantics and semiotics, which I won't go into. The lesson in learning is that remembering isn't some kind of cognitive decoding kind of process. It's a physical process. And it's a physical process based on experience and perceiving. To learn about something is to experience that thing through all the facets of perception, sensation, reflection, and interactivity. And that takes us back to the proposition I stated at the beginning of this talk. The graph is the conceptual basis for Web3 networks. We've seen that. The graph is a distributed representation of a state of affairs, and in the case of a social network, or a social graph at least, it's created by our interactions with each other. In other graphs, it's created by interactions with other entities or other nodes. And the graph itself is at once the outcome of these interactions, but also the source of truth about these states of affairs. The graph, properly constructed, and we can talk about that, we will talk about that further in the course, is not merely a knowledge repository, but it's a perceptual system that draws on the individual experiences and contributions of each node, of each person, of each neuron, which, as an aside, for the purpose of a beginning of discussion of ethics, is why each node and each individual, each person, is important. And this informs not only what we learn, but how we learn, creating new learning contents, new forms of learning, and new literacies required in order to undertake that learning. So that's basically the presentation for graph. It's something I've thought about for a long time. And I think this represents a bit of a moving forward of some of those views, prompted especially by the idea of blockchain, and especially by the idea that the network itself can be the source of truth in certain knowable ways. And that's the fundamental problem that blockchain was created to address. It was created to address the problem, what they call the Byzantine generals problem, the problem that you might have bad actors in your network. And how do you get truth anyways? We'll talk about some of those mechanisms in the future, but for now, I'm Stephen Downs. This is the conclusion of week 3 of the eLearning 3.0 course. I really look forward to